Okay, so before starting this video, you should have completed Atoms and Elements video. So that's chapter 2.1. This is chapter 2, section 2 in the Mater textbook, Bonding and Bonds. Okay, so let's draw our hydrogen atom, H plus. So this is our positive charge. Just actually draw this correctly. Positive charge, electron on the outside to balance the inner charge. So we've got, this is our hydrogen atom that we just talked about. And so if we have another hydrogen atom, or any sort of other atom that interacts with that, that could form a bond by overlapping these electron orbitals. So the electrons, because they're on the outside, are in charge of bonding. So instead of just hovering around this nucleus now, it can hover around this nucleus and these form a figure 8 pattern. And so this molecule now would be H2, because now that there's a bond. So when you think of bonding, you're probably thinking about covalent bonds, which is the first type of bond that's formed. So these are strong and, as far as we are concerned, permanent. This is not a chemistry class. So chemistry makes these permanent bonds and changes them and moves them around, but for us, we're not doing any of that. And each element that we're going to be dealing with, so we're going to be dealing with these elements, which is called chinops. Each element has a different number of covalent bonds that it likes. And you can tell how many it likes by looking at the periodic table. So H is all the way on the left. It's atomic number 1. It likes 1 bond. And then it gets trickier from that. So C, this is atomic number 6. And based on its position, we know that it likes 4 bonds. To the right of that is nitrogen, this is 7. It likes 3 bonds. Oxygen is to the right of that. It likes 2 bonds. Phosphorus is beneath nitrogen, but it actually likes 6 bonds. You don't have to worry too much about that. And sulfur, which is directly beneath oxygen, it also likes 2 bonds. And again, you don't have to worry about either of these. So these are the 4 that you're going to be seeing the most often. These very, very rarely, just because of the content of this class. Okay, so I'm going to scroll down a little bit here. Give us some more room. So what does that mean? This carbon likes 4 bonds. So these covalent are strong and permanent, and they're drawn as a solid line. So what that means is when you see a C, it needs to have 4 lines coming off of it. And then I like to fill out the rest of these with H's, because H only needs 1 bond. So this H is now happy because it's attached to 1 bond. This carbon is now happy because it's got its 4 bonds. So we have something like this, CH4. This is a compound called methane. And we'll do a little thing on figuring out formulas based on structures in a bit. You're never going to have to go this way, give you a formula and you draw it. You'll only have to go, if I give you a molecule, you tell me the formula, but that's a different lecture. This is just to show covalent bonding. So each one of these lines is a covalent single bond, because it's a single line. There are such things as double bonds. And so when this happens, each of these lines still counts as 1 covalent bond. So carbon still needs 4 bonds coming off of it total. So this would be 1, 2, 3, and 4. And again, 1, 2, 3, and 4. So I'm going to number that. 1 bond, 2 bonds, 3 bonds, 4 bonds. So each of these carbons still has 4 bonds. They're still happy. I'm going to fill out the rest of these bonds with H's, because that's really easy. So these are still covalent bonds. These are covalent double bonds, because there are 2 lines. So double bonds mean that these are held together even tighter than single bonds. So if there's more bonding, more lines here, then it's stronger. So these are stronger than those. And there's even triple bonds, which I don't think we're going to see in this class. But triple bonds are still covalent because they're solid lines, but there's 3 single lines, and as you'd predict, as we saw in the double bonds, each one of these counts as 1 covalent bond. So there's 1, 2, 3 bonds here, and there's our 4th bond there, and our 4th bond there. So each of these carbons is in its best energy state because it's got 4 bonds, and that's what makes carbon happy. So these are covalent bonds that you'll see: single, double, triple. And you can have mixtures of single and triple, single and double, and we'll see double bonds a lot. So don't let that fool you. Okay, and so when you have a single bond, you have more H's. When you have a double bond, you have less H's because 2 of those bonds are connecting this way instead of connecting out that way. So it's something to keep in mind for lipids, which we'll come back to. Okay, so after covalent bonds, those are strong permanent bonds, we also have something called noncovalent bonds. So noncovalent bonds are weak and temporary, whereas covalent bonds were strong and permanent. These are not that. Non-covalent. These are weak and temporary. And so where these occur is between water molecules, for instance. These also occur between strands of DNA. This also occurs between sugar molecules. This occurs a lot. So our covalent bonds are here and here. Our non-covalent bond is here. It's a dotted line because it is temporary. So the best way that we can show this is with a dotted line. So let's draw another one over here. And this is how water molecules interact. So here's covalent, covalent, non-covalent. So a great quiz question would be if I put a number by the bond, like here's number 1, here's number 2, here's number 3. Name the type of bond shown. It's like if this was 2, and if that one was 3, and that one was 1. And you would say either covalent or non-covalent.